Now I'm recording. Anything you say can and will be used against you in a court of anyway. So f of 3, if you plug 3 into this equation, you get out 27. And if you plug in 1 into this equation, you can see that you get out 0. And then you subtract 3 minus 1. So this again is the delta y, right? Change in y. And this is the change in x. And 3 minus 1 is, did I do something? That's wrong.
27. It's 24.
24. Sorry, no wonder I did something wrong. That's 24. And if I plug in 1 in here, I get out 0. And then 3 minus 1 is 2. So I get that slope of that secant line is equal to 12, right? And so that has a couple different names. That has the average rate of change, and it's also known as the slope of the secant line, and it is also known as the difference quotient. Difference quotient, which they sometimes use. Quotient means division, okay? And in general, that would look like f of x plus h minus f of x over h, where h is the distance from here to here, right? Yes? You understand that? Okay, so f of x plus h, so in this case this is f of oh, that's not, okay, I went backwards instead of forwards. So in this case, this is f of x plus h. This would be f of x, right? And this would be f of x plus h. This would be f of x. This would be x plus h. And this would be x, right? Where h is equal to 2. Yeah? Yes?
What is
Yeah.
it say to the right of delta?
To the right of delta.
Yeah, right here.
This, that's just delta y.
Oh, delta 1.
Change in y, and that's just changing it. But, so, if this is f of x, so this would be f of x plus h. It depends where you start, right? Okay? Now, so this is the basic formula for the difference quotient. F of x plus h minus f of x over h. It's also the basic formula for the average rate of change. It's also the basic formula for the slope of the secant line. Okay? Now, unfortunately, you don't always want to find the average rate of change. You want to see what happens as, oh, have this get down here. You want to see what happens. You want to find the exact rate of change. So say you want to know the exact rate of change right at 3, okay? Well, you could take this line here, watch this trick, okay? And it would get steeper, right? As this point, or say I want to find the rate of change exactly at this point. Let's do it that way, okay? To do that, I would take this point right here, yes? And I'd slide it down, and I'd make my delta h's and delta y's smaller and smaller and smaller. So if I took this curve and I moved it through those 2 points, it's kind of hard to see with my all my stuff all over the place. But if I did that, then that line would look something like this. And as I get closer and that's not very good, that last one. Okay? But as I get closer and closer and closer to the, as I bring a point closer and closer and closer to this point, right? I would get closer and closer to the exact rate of change at that point, right? You understand that?
Yep.
And that rate of change is called the instantaneous rate of change, okay? So, I'm going to have a slide here in a second. Where is it? I got it. PowerPoint. It says go to slide 11. Slide 11. Look. So it says in calculus, you don't have to write all this down. We often want to define the rate at which the value of the function y equals f of x is changing with respect to x at any particular value, x equals a, to be the slope of the tangent line to the curve y equals f of x at x equals a. The problem with this is that we only have 1 point, and our usual definition of slope requires 2 points. So I'm going to use this example, which is on this slide, I think, slide 13. Slide 13? Yes, this one. Okay? So what does the question say? We're going to actually do this problem because it's a, what is, well, find the equation. Okay. So I'm going to take a picture of it so it doesn't look confusing to you guys. There, okay? So I'm not going to do it with a cubic function that we just had, because when you do this with a cubic function, you have to cube x plus h, and the algebra becomes very cumbersome. I mean, you might be asked to do one in your homework, but I'm not going to do it now. I'm going to kind of keep it simple, okay? So what you want to do is I'm going to add to what they want you to do here. Okay, write an expression for the slope of the secant line and find the limiting value of the slope as q approaches p along the curve. So if I were to graph this, let's graph it over here. Not a very good, I should use solid lines below. Okay, so y equals x squared plus 2. That kind of looks like a parabola, right? And it goes through 2, something like that. And the first thing, so what you want to do is find, we're going to call this f of x equals -1. So when I plug in -1 in here, what do I get out? -1 in here, what do I get out? 3, okay? So this is the point, -1, comma, 3, right there. And I want to go ahead of that point. So say I go to this point right here, and the first thing I'm going to do is draw a line with the arrows on the end. Line tool. Where's my, oh, I'm hiding that stuff. Okay. Okay. I'm going to draw a line through these points. Okay. And this point is going to be f of x plus h. So it says write an expression for the slope of the secant line and find the limiting value as the slope approaches, as the limiting value of the slope as q approaches p along that line. So I'm going to write this as f of, first we'll start with the general formula. F of x plus h, I'm having trouble with my Moby here. F of x plus h minus f of x over h. Okay? And into here, I'm going to plug in f of x plus h, which is going to be just -1 plus h squared plus 2. That's f of x plus h, because what I'm doing, I'm taking x, which is -1, plus h. So this point is -1 plus h, comma f of -1 plus h, plus 2 minus f of -1. Just bear with me for a second, guys. Over h. Do you guys understand what I just did? Oops, f of -1. Let me write out what f of -1 is. It's -1 squared plus 2, like this. And there's like there's like parentheses. You follow? This is the point -1 plus h, comma, f of -1 plus h. This is the point, this is f of -1, okay, comma 3. Because if I plug in -1 in here, I get, excuse me, it's negative 1. Sorry. Yes, sir.
Where'd you get the plus 2 in the middle?
Plus 2, okay? Plus 2 from this function. So what I'm doing,
okay,
I'm taking this point, negative 1 plus h. That's the x coordinate, okay? And I'm plugging it in here. And when I plug in negative 1 plus h, I square it. I have to add 2 to it. This is the y coordinate. This whole thing is the y coordinate, okay? So this is like y2, and this is like y1, okay? And this, h, is like x2 minus x1, because it's the difference. If I take negative 1 plus h, and I subtract negative 1, I'm going to have h, right? That's the difference, okay? So if I simplify this, I'm not going to simplify it yet. What I want to do is I want to bring this point closer and closer and closer to here until I find the exact slope of this line right there, okay? And the way I do that is by taking the limits as h goes to what? 0, okay? And this expression, the limits as h goes to 0, okay? It's not the same as the difference quotient. This is called the instantaneous rate of change, okay? Instantaneous rate of change is called a couple things. Instantaneous rate of change. It's also known as the slope of the tangent line and it's also known, it has another name. Anyone know what the last name is? Yes, sir. Yes, very good. So the other name for that is the derivative. In the next chapter, this chapter all deals with the limits, but we're using the definition of a limit to find the derivative. So it's the instantaneous rate of change of a point, the slope of the tangent line, and the derivative. So let's just do the math here, guys. When I do the math, you learned this already. Did you learn this already? Some of you did. So I'm going to go negative 1 plus h squared. If I do the algebra there, I get negative 1 times negative 1, which is 1. I get negative 1 times h twice, which is minus 2h. I get h times h, which is h squared, right? Plus 2 minus this mess, which is negative 1 squared, which is 1, plus 2, which is 3. So it's just minus 3. Yeah? Follow what I did? I'm just doing algebra over h, and I take the limit of that as h goes to 0. Now, fortunately, these things will always simplify nicely, okay? And this 1 plus 2 minus 3 goes away. See that? I get 1 plus 2 is 3 minus 3 goes away. And so now I rewrite this as the limit as h goes to 0 of negative 2h. Hey, got that. Plus h squared over h. Are you writing any of this down? Or trying to focus? Or what? Might be a good idea. Okay? Although this one is in your book, so you can, however you want. Now what can I do?
You can cross out.
You can cross out some h's, right? Just one from each of those, and this becomes the limit as h goes to 0 of negative 2 plus 1h. Everyone follow the algebra I just did there? I kind of did 2 steps, but I didn't. Yes, sir?
Why do you get rid of the 1 and the 3?
Because 1 plus 2 is 3, minus 3 is, right? Turns into 0. Now I can take this 0 and plug it in, and what do I get? Negative 2. So what that tells you is the slope of the tangent line, not this line right here. Okay, let's see if I can erase this. Can I erase that? How do I do that? File, edit, cut. I can erase that. And the slope of this line I make a smaller eraser. The slope of this line right here, see that line right there? The slope is -2. M equals -2. This line right there. And then they might ask you to find the equation. So the next step would be to find the equation of the tangent line. And so what I know from up here, okay, I know the slope and I know what point that it goes through. This is the point x comma f of x, right? X comma f of x, which is -1 comma 3. So if I plug in -1 in here, I get out 3, so it has to go through this point. So, and I know the slope is what? -2. So I'm going to use the point slope formula, y minus y1 equals m times x minus x1. And when you're doing calculus, this is kind of a better formula to use because you will usually be given a slope and a point, not the y-intercept or something like that. And that's why they teach you this, because it's kind of easier to use if you know the slope. So -2 goes in there, and the point that goes in here is -1 comma 3, right? And plugging that stuff in, I get y minus 3 equals -2x plus 1. And if you don't like point slope form, which is okay with me, you could always change it into slope intercept form, okay, if you like, but you don't have to. Minus 2x minus 2 plus 3 would give you plus 1. So that would be the equation of that tangent line. Questions on that? Okay. Then you have something else called the normal line, okay? Find it, and then they'll ask you, find the equation of the normal line. Find, and this is really easy, you just have to know what normal means. Find the equation of normal line. Anyone know what normal means?
Means like flat in relation to the thing.
That actually means perpendicular. It's the opposite of what you think. Okay? So normal means perpendicular. So here we go again with this thing. Okay? Okay, stop doing that. And undo, 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 undo. You just have to be patient. Normal means perpendicular. Okay? So all I'd have to do to find the equation of the normal line, if you know the slope of the line, what's the slope of the perpendicular? What do you do with that slope? Flip it and make it negative. Okay? So all I have to do is plug in exactly the same point, y minus 3 equals, instead of -2, what would go here? 1/2 x plus 1, okay? And you can change that into slope intercept if you want, but you don't need to. And what that is, that's the equation of the line that goes through that same point, except it is perpendicular to the tangent line at that point. And a lot of times you want to know, like, what a force, like in physics, you want to know what's the perpendicular force at that point or something like that. And so that's why you would want to know that. But that comes up a lot, and you want to know. I know I only have a few minutes, okay? But I want to try to get through this very last thing, because I kind of went too slow. So if you have f of x equals, I gotta get that slide really quick. Slide, oh, it's not a slide, it's on your homework. Where is it? Here. I got through this in the last class, but for some reason I didn't get through this one in this class. But I think I was gonna do this with you, but I'm just gonna kind of lead you through it. Okay? If you have an equation like y equals 1 over x, y equals 1 over x looks like, if you were to graph it, okay, it looks like, you know what it looks like. It looks like this. Don't you know that? You know that, right? Okay? And so what they do, this is a little bit different because it's not a quadratic function. It's a rational function. So what they do with this is they use the exact same formula, except instead of calling this x, they call it a. And it's 1 over a plus h. So for x, you plug in a plus h. Okay, for f of x plus h. And this is f of x over h. And then they find a common denominator. This thing simplifies down to this, and this a go away, and what you're left with is negative h over this, and then this and this cancel, and you get a negative 1 on top. And then this formula right here, look at this example in the book if you can. The algebra is a little bit tricky, but we've only got a few minutes. This formula is a general formula for the slope at any point. Okay, so that's the equation of the derivative. Okay, so for instance, if I want to know what is the slope, watch. If I want to know what is the slope at 3, what is the slope of this? What is the slope of this curve at positive 3? Negative 1/9. So if I go over here to 1, 2, 3, the slope of the tangent line at that point would be down 1/9. Okay? The other question they ask you, where does the slope equal negative 1/4? So you set this slope equation, which is the derivative, equal to negative 1/4. You cross multiply, and you get negative a squared equals negative 4, so a squared equals 4, which is a is plus or minus 2. So what that means is at plus 2 and at minus 2, the slope of this line is negative 1/4. So that should line up with there. And over here, the slope of the line is negative 1/4. So that could tell you the slope at any point. Okay. So this is how you find you use this general formula to find the equation of the derivative at any point, not just at a specific point like I did in that first example. And that's kind of what's on your homework. And these examples, a couple of them I stole out of your book, but I'll post the PowerPoint as well, and you can look at that. And what else?
What's the homework?
Homework is pretty short.
Yes.
Okay.
Yes.
It's not as bad as it's been. Okay. It's if I could find it. 1 through 52 all. No, I'm just kidding. Okay. It is page 92 right here. Watch. Here it is. And now you could go hang out at the club and you could use the famous calculus pickup line. At least guys can. You know what the famous calculus pickup line is? You can say, hey baby, can I be your derivative so I can be a tangent to your curves?